Okay, cool. So hi, everyone. I'm Katherine. I am part of a great team working on memorization and language models. So I'm presenting the work of a lot of different people. They've all been really wonderful to work with. And this is, like I said earlier, work that spans, I think, 4, maybe 5 papers now at this point. So we'll talk about them interwovenly. And if you have any questions about anything in particular, feel free to chime in. I think we also have questions at the end. So I may also, depending on what question you ask you to ask it again at the end, in case I cover it later already. Cool. So I feel like this group might know that language models model language. And in particular, what that means is that they learn a probability distribution of a sequence given the previous tokens. So probability of word given previous words. And what that means is you get things like the students open their books with high probability, open their laptops with high probability, and open their pencils with maybe a lower probability. Mm-hmm. So with that, we actually find that language models are pretty leaky, and this XKCD illustrates it really well. So you have long live the revolution, and our next meeting will be at, found them, the docs at midnight on June 28th. And it makes sense, right? Because these language models are trained to predict the next word. So you're literally doing this task. And it turns out we can do exactly this. So for GPT-2, we can give it a prefix, and then we can extract out the memorized text. And in this case, we extracted out someone's name, phone number, email address, and then contacted them and said, hey, is this your contact information? How did this end up online? So it turns out they had put it somewhere as part of a GitHub README, and with the intention of people who, wander onto the README to reach out to them. So this kind of gets into something that we'll talk about a little bit later about like what is private information, what sort of information is private, and what sort of contexts surround private information. So instead of looking at privacy as a binary, like, yes, this is private, or no, this is not private, we can instead start to think about like in what contexts things are private information. So I understand that that's maybe a little bit of a departure from some other ways we may traditionally think about it, where you say like, oh yes, this is protected information, we can't cross it. But this is very reflective of how we live our lives. So we'll talk about that in the second part. For those of you who weren't here in the beginning, the first part of this is going to be a little more technical, and the second part is going to be a little more discussion about language as a domain. Cool. So we can quantify this, and we discover that memorization scales with model size. So language models have been growing in the last, since they've been around 5 or 6 years. And today, this is already out of date. So the largest number here is 8 billion parameters, and we have models that are 500 billion parameters now and up. So the most important part of this is looking at the up and to the right. So on the y-axis, sorry, it's not labeled, is the likelihood that we can extract a particular training example. And that likelihood increases as our model size increases. So we looked into that a little bit more, and we were like, that's not great that we can extract so much training data. What do these examples look like? So we took a look at them and found that these examples appear in the training set this many times. So this example over here appears over 5,000 times. And this one 500 times. That's kind of a lot. So what happened? Well, if you look at the text, a lot of them are things like templated text that's like an artifact of the way text arrives on the internet. So you might get like multiple different websites advertising the same information. You might have things that are just very common, or like if you have a book, maybe some copyrighted text that gets reposted many, many times. And we find that the more you repeat the data, the more a particular example is repeated in the training data, the easier it is to extract. So on the x-axis here, we have amount of times that the data was repeated. And on the y-axis, we again have the probability that we can extract that training example. And as you can see as well, like the models, the extraction likelihood also goes up as the model size increases. So we can look into that a little bit more, and we find that a lot of the training sets that we use for training these language models have a lot of duplicates in them. For example, C4 in the training set has like over 3% duplicate examples. And Real News has something closer to like 14% duplicate examples. And that's not because people didn't try to deduplicate their data. They did. So each one of these data sets that we see here, C4, Real News, LM1B, Wiki40B, were all deduplicated with some strategies. Unfortunately, doing a thorough deduplication is really hard and complicated and computationally expensive. So that's why we end up with still quite a number of duplicates in the training set. And also importantly, we have duplicates in the validation set, and we also have duplicates in the training and validation set. So across training examples that also appear in the validation set. But detecting duplicates can be pretty challenging, and it depends on how exactly you define it. So if you have almost exactly the same phrase, but one word is different, is that a duplicate? I don't know. It kind of depends on the word. It kind of depends on how long the sentence is. Maybe depends on how likely the rest of the sentence is compared to some other sentences. So there's no clear, hard and fast, this is a duplicate, this is not a duplicate. So in this work, we defined it in two different ways. One, which was a near duplicate, and the other one was an exact substring of length 50 tokens. So you can do that in different ways depending on your application domain. And there are many strategies in the plagiarism literature in particular for looking at duplicates. And this is true for, anything else, any other domain that you're interested in. So like images as well, you probably want to define some notion of a duplicate. Maybe that's like taking the same photo from different angles would be considered one, or changing any data augmentation that you might do might also register as a duplicate. It really depends on your specific application. I think there was a question. Was that true? Or did that? Okay, I don't see any anymore. Okay, great. Yeah, so what we can do is we can deduplicate these data sets with these methods, and then retrain the models. And when you retrain with the models, so this is the original model, and these two are both deduplicated with the two different strategies that we mentioned before, you get a 10x drop in memorization for unprompted generations. So that's pretty substantial. And you are removing quite a large chunk of your data sets. In particular, if some of those examples are repeated like 5K number of times. It's also great to see that these deduplicated models are better when you look at perplexity as well. So what we have here is, sorry, I'm going to move my little Zoom screen here. What we have here are those three different models. So here is the original model, and then the two deduplicated models. And then I'm looking at different parts of the training set here. So this is the original data set, and then this is just the data in the training data set that has duplicates, and this is just data that are unique as determined by our deduplication methods. So we can see that the original model has a much lower perplexity on the duplicates, which makes sense. It's seen it many more times. But the two deduplicated ones have a lower perplexity. This one's debatable on unique examples. And when we look at data sets that the model wasn't trained on, so LM1B and Wiki40B, that's much more clear. So these two deduplicated models have a lower perplexity than the original model. Cool.
Can you clarify what perplexity mean like precisely? Is like quality of the sentences in some way?
So perplexity is kind of like a measure of surprise. So it's like how the larger it is, the more shocked by a sequence the model is.
I see.
So the lower it is, the more likely it is that the model has, the more likely or more unsurprised the model finds it.
I see. So it's more of like it's on the real data, a metric derived from the generative model, like the likelihood or something like that.
I'm sorry, you cut out for the first part. Can you say it again?
So It's a metric derived on real data. So if you feed in the real
Oh yeah,
real n-grams, and the model assigns a metric or like likelihood or like what's the probability that it has seen it or something.
it's like the probability. It's a measure of how likely those examples are. So yeah, you can do token-wise perplexity, which is like each token in the entire sentence, or you can do sentence-wise perplexity as well. You can also do document-wise. So just like, yeah, a measure of how likely something is.
Nice, good, thank you.
Yep. Cool. So these deduplicated models just seem better. And we've been pretty happy to see that most of the language models that have been trained since this paper came out deduplicate their data. So what about examples that are not seen that many times, but are still memorized? Can we find those examples? So we try to do that by defining something called counterfactual memorization, which is looking at the likelihood of a particular example when that example has been seen by the model versus the likelihood of an example, the same example, when the model has not seen that example. So if you were to do this exactly out, you would be training a lot of models. So we didn't do that. We did something that was a little bit more relaxed, where we divided the data into many different folds, k-folds, and then trained many models on subsets of the data set. So that means that we have some models where some set of examples were seen, and we have another set of models where that subset of examples were not seen. And we compare the likelihood between those two different sets of models for each example. So we can get some measure of the number of duplicates versus the memorization, the counterfactual memorization as we defined it before, in this way. So you can see that we do get some separation here. So there are some examples that have a few number of duplicates that have a large counterfactual memorization. And when we looked at those examples, we saw there were things like things that were maybe a little bit out of distribution, like capitalization or punctuation changes, or like foreign languages, or things that with specific formatting. So kind of makes sense. And this is what I was describing earlier about the accuracy for the models that had seen an example versus the accuracy of examples that had not seen that example. And this is what it ends up looking like for one of the data sets. Cool. So let's go back to this. When we extract training data, we're often using prefixes here. And it turns out that the longer the prefix you give, aka the more information you have about the example, the easier it is to extract the remainder of it. So there's a notion of discoverability, where it can be a little bit challenging to measure the upper limit of how much information is memorized, because with more knowledge of what's in the training set, you might be able to extract additional information. And just because you weren't able to extract an example from the model doesn't mean you can't reconstruct it with a better attack. So this is just looking at the amount of context we have on the x-axis versus, again, the ease of extracting a particular example. So we again see it's up and to the right. Cool. Any questions? I'm going to take a little pause right there.
So I think I'll ask one. So the deduplication, like it's you said, like it's a very hard problem. Like
Yeah.
So it's more like it's always gonna like miss something. Like for example, like some basic hacks, like I can write my SSN like as a number, or I can also write like the first digit is this, the second like is this, and the third is this, and all the information is like still contained within, like all the private information is still in the training data. Is the hope is that the network may not be able to even like be invariant to this augmentation that is present there, or is it that the network is just so powerful. It has like 500 million parameters that it will figure it out. Like for example, in images, like it will just learn to map everything to the same embedding and end up memorizing it. So it's like, do we get the benefit from it, or is it more like it's sort of like that the issue will still persist?
Yeah, so there's other work that's looked at, like if you were to insert a particular example, how easy it would be to kind of discover that that example had been inserted. So that's looking at like canaries. So this paper is called Secret Share. And what they do is they look at the beam of the language model, which is basically like the probabilities of distribution over many tokens, and then find that like if you insert something like my social security number is blank, then that 9-digit number is much more likely compared to other 9-digit numbers. So it's a little bit, it's kind of like column A, column B for your question. It's a little bit of both. Like it's definitely true that if you've seen an example, you can, from the Secret Share paper, if you were to try to do like a membership inference thing where you're just trying to confirm that this example was seen or not, and you already have the example, you would maybe likely be able to find that out. And then also, if you see an example many, many times, that's also likely to be memorized. Does that answer your question?
Yeah, kind of. But yeah, maybe we can come back to it at the end of the talk. Yeah.
Okay.
It's like a broad discussion topic, to be honest. So we can come back.
Cool. Sounds good.
Thanks.
Okay, I'm going to take a pause here and we're going to move on to the second part. So talking about like what privacy means for language modeling. I hope this inspires discussion. So if you're following along at home, now would be a great time to start paying attention so that we can have a better discussion later. So this is, what does it mean for a language model to preserve privacy? And how do we use language? Well, we use language to communicate and to express ourselves. And that's very broad and very vague. And that means that the privacy concerns for language are just as broad as privacy concerns of those of real life. So let me give you an example. Let's say Alice turns to Bob and says, I'm getting a divorce. And Bob says, oh no, what are you going to do about the custody of the kids? So what's happened here? With the information that Alice has given Bob and information that Bob already has about Alice, Bob has made an inference about another problem that Alice might be going through. So maybe Bob turns around and says to Grace, did you hear Alice is getting divorced? And then depending on the relationship that Grace and Bob and Grace and Alice and Bob and Alice have, that could or wouldn't necessarily be a violation of Alice's privacy. So maybe Alice told Bob, don't tell anyone. But maybe maybe Bob and Grace are married. And so when Alice tells Bob, she kind of infers that Grace will probably find out. So it really depends on these social connections that we have with each other and the type of information that we're sharing. So if you're thinking about things like HIPAA compliance, so that's for like medical information, your doctor can share more information with you than they can about your family member's medical history. But if your doctor needs to pass that information along to another doctor who may be operating on you, then they can pass your medical record along to them. But all of that is governed both by our societal expectations and also by the laws, depending on the context. So language is extremely contextual. And just because you're sharing information to somebody doesn't mean it's public. And just because it's private to some people doesn't mean it's private or public. And it's all just depending on context. And identifying all of that is really, really hard. This is particularly challenging when people post information online because the intent to share might be different depending on what people understand. And that's something we can circle back to as well. So actually, instead of forgetting the secrets that we're told, we sometimes memorize those secrets and then judge whether or not we can share them depending on the context. And if you're sitting at home thinking about how this relates to language models, language models don't really have this understanding of context. And that information is often beyond the data that's given. So, and also people have asked, like, should we just have our language models not memorize anything, or should we just try to explicitly memorize things? And that way we can refer back to exactly what it was that was memorized. It's not quite clear what the right answer is. And sometimes memorization is actually a good thing. In the case of like question and answering, that might be one. And then in the case of like, you know, my social security number is, that might be bad. But things that are quotes. So for example, if you're memorizing things on Twitter, you probably want to get a tweet from a public persona exactly correct. So if something Trump tweets, like tariffs are the greatest, then you probably want to memorize that. And if it's something that, you know, a private citizen, Sally Smith, said, Sam is the worst, maybe you don't want to memorize that. And then there are things like common phrases, whom it may concern, that you might not care if it's memorized or not. Facts, which depending on like what is a fact, maybe you don't care if it's memorized or not. Like Christmas is celebrated on December 25th, but something like Christmas is celebrated in the winter isn't true everywhere, even though it is, you know, true in many parts of the world. So it can be difficult to measure the harm from memorization, and also difficult to understand in what situations it's appropriate. Cool. So I've said this a couple of times now, but privacy isn't binary, and the violations that you can get from privacy violations kind of range in severity. It's all heavily dependent on context, and it importantly can also change with time, as maybe, you know, Bob and Alice's relationship changes because Bob shared a secret of Alice's from before. Maybe Alice stops sharing information with Bob in the future. So we can look a little bit at the current methods that we have in NLP for privacy preserving. So for training privacy preserving models. So one is removing private data. So text sanitization. And it's really challenging to create a general purpose text sanitizer. And I'm specifically saying general purpose in this case because some specific applications, you can be a little bit more clear about what private information is. So depending on your application, it may be better or easier or harder. But some things that you might run into are private information doesn't have just one format. So you're like, I'm going to get rid of all email addresses. All right, well, we're all academics. Surely you've seen someone write on their website, last name @website.com. So there are many, many ways of writing and sharing the same information. Additionally, language is constantly changing. So if you get things on TikTok where there's like content moderation, people will frequently change the spelling of their words to make it very easy for people to read it, but very difficult for machines to determine what someone is talking about. And privacy is also very context dependent. So we're throwing Bob a surprise party. Probably shouldn't tell Bob, but it's probably okay to tell it to a lot of other people. What about differential privacy? So differential privacy, some of us may be familiar. Essentially, it's if you take two models and they differ by one record, you shouldn't be able to tell the difference between those two different models. And some of the challenges here are that it makes some assumptions that there is private and non-private information, and that you can identify what that private information is. It's also difficult to sometimes define the units of what private information is. And also, one important difference is that an assumption that private information will not be shared or repeated many times. So we can talk about each one of those. Let's go back to this. So what if Bob says instead, did you hear that Alice is in a custody battle? And then Grace infers, does that mean she's getting a divorce? So what's the secret here? What's the private information here? Is it that Alice is getting a divorce? Bob didn't really tell Grace that Alice was getting a divorce, but Grace, with the additional information that she had, could infer that. So trying to figure out like where exactly the borders of this information is can be pretty challenging. And also trying to figure out the group of people that would be okay to share this with can also be quite challenging. So for DP, some people have proposed looking at like group level privacy. So if you have like a company, maybe everyone in that group is considered part of like one record. So this one is also challenging. So shared information can still be private. So an example of that is the Panama Papers. So a group of 300 journalists, for about a year, were talking about the Panama Papers many, many times over in their private chat. And that means that things like Panama Papers are going to get repeated. And shared information within this small context still should stay private among the journalists. And repeated information, like repeating the words Panama Papers, should still remain private in that small context. Another example of this is like company credit cards, where the company's credit card information might be public within the company, and it might even be emailed around in plain text, but it's still intended to be private. So if you're thinking about how this impacts language models today, where a lot of our data comes from scraping the web, I'm going to ask you to think forward in time, where in the future, all of that data might not be just publicly available on the web. Cool. So what are we supposed to do about that? It's challenging. We kind of talked about this a little bit earlier. Can users actually consent? Do they know what they're doing, especially when they post publicly? And informed consent is extremely hard to have in this context. One person's data can include multiple people's information. So if we're looking at Bob's chat records, he has many other people's secrets, including Alice's. And if you're posting on Reddit, if you're posting on a subreddit, you might intend for the audience to be other members of that community and for it to not leak out of that community. So there's this notion of like contained and discoverable information and how easy it is to find something. So same thing with like GitHub. So the person who posted their contact information intended for it to stay within people who used that software. And this is also true for like Codex got into some heat a while ago where people were able to get like security keys out of that. Well, probably people were like, oh, who's going to look at my, code repo? No one's going to find that. Like, what are they going to be searching for to find that? Yeah, well, it turns out when you put it in a language model, it makes it way more discoverable. And part of that is because there are checks on things like search engines that try to filter for things like that. And also because when you're searching for a security key, information about security keys on Google, there might be other results that are more relevant to you, but when it's like searching in the context of a language model, that might be the next most likely token. So it's this challenge of like, can users consent? And there's also a challenge of like, this is what we just talked about, that something that's publicly available doesn't mean it's publicly directed. And that's just like the really innocuous stuff. Data can also be shared without consent. So an example of that is when we were doing the extraction paper, we found a chat record between two individuals. And the language model reproduced a chat transcript that wasn't exactly the same as the original, but was about the same topic. So it was about trans rights. And the two usernames had the same opinions. So what information gets leaked there? And that data was part of like a Gamergate data leakage. So it wasn't posted online by either of the two individuals. And we have that with other things too, like the Enron emails data set or Hillary Clinton's campaign emails, etc. So data can be shared without consent as well. As we talked about before, deploying these language models just means increasing the scope of potential people who see that data and discover that data. So what can we do about it? We can train on data that's intended to be public, note the word intended, not the word is, and then fine tune on user contributed data locally. But this is challenging as we enter into a world where data is even more important for our language model training. So I'm going to pause there and leave these questions on the screen. So if you want to chime in with any questions, now would be a good time.
I had a question. Thank you very much. This has been really interesting. I have a bunch of questions, but maybe I start with this one. So this notion of consent that you mentioned, it's not really clear what that means. I agree. Philosophically, it's impossible to. So when someone sees something, it's always with them, no matter what question you ask them, it might have affected their opinion somehow, and their opinion might have some secret information about someone else. So if you want to think about consent in this way, does any, like a consent from any person could reveal a lot of information about other people? Like when this consent becomes actually something that you're, like, how do you make sure that the consent is just related to that person and not about other people's secrets in any scenario? Is there anything that this consent could just mean that this person is only revealing their own information and not others?
Yeah, this is much easier to think about if you have a specific application in mind. Like, for example, if we were looking at chat transcripts with, like, I don't know, maybe they're like transcripts of call center lines, like that's maybe easier to think about consent there. It's much harder when you're talking about like general purpose, or when you're talking about like communication like emails that are kind of by definition between multiple parties. So I think this will come down to the exact product or the exact use case that this ends up in.
I see, but so what I can imagine, that person who had a chat with someone else has the right to start writing a summary of that chat, right?
Yeah.
As a personal memo. And this is not related to that person. This is something that I produce. This is, if I give you consent on this, this is still could be, have some information about someone else because it's a summary of my chat with them.
Yeah.
And it's hard for me to distinguish between these two cases. How can you, just because some transaction involves multiple parties doesn't mean that the consent, or let's say it this way, just because the transaction involves just only one party doesn't mean that the consent in this case does not reveal information about other parties.
Yeah.
And it's hard for me to distinguish between these two settings just based on how many people were involved in that transaction.
Yeah, I think that's definitely true. I think like this is kind of like someone writing a memoir of their life and then like spilling everyone's secrets at the same time.
Yeah,
There's like social pressures and social norms against doing that. And I think this also depends on like harm and scale. So like if you have a lot of text from one individual, then that might be more problematic, both because like there might be more memorized content from that individual, and therefore more likely to be extracted, and also just more surface areas for kind of like information leakage. If it's just like one sentence one time, it's much harder to extract that information unless you have some kind of like background or additional context about it. So it's kind of you're trying to measure degree of harm here.
Yeah.
Yeah.
Yeah, this is I think a very interesting philosophical question that is probably context dependent. So yeah, thank you very much.
Yeah, but it's hard to get like blanket consent for anything. Like if you just have like, you know, all of your emails or all of your chat messages stored or used for language model training, that's really hard to give blanket consent for.
Right. No, but this is also something that people should ask themselves. Like, if I might be okay, I might not care about my privacy and give consent to all my data to any company that asks for it, but is it ethical to do, because that might contain a lot of information about other people.
Right. Yeah. And what can you infer about that? Like if I'm looking for, you know, someone's location and I know that you spend a lot of time with them and I have access to your location, I might be able to pin them down as well. So it kind of also depends on how like targeted attacks will be in the future. If it's like something like, if the motivation is like identity theft, and you are specifically targeting, like the way that I might imagine that going down is like, you do like a blanket campaign to see if there's good candidates for mining information from, and then you do more targeted attacks on those specific candidates, where you try to collect more information, more personal information about them, and then use that to extract additional information.
Right.
So yeah, it's good to write out some scenarios as well, like what we think might happen with this.
Yeah, exactly. Yeah, thank you so much.
Yeah.
To follow up on the notion of context here, like if you consider the problem of privacy preserving language models, for example, what I want to ask is like, is this problem like well defined, or like even more strongly, is this an like ill-defined problem if we want to write an objective for it? Say the language model generates like that my cell number, like our cell number is this. Now, this information, as you just discussed, may not be privacy concerning. Maybe I'm making it available on my website. And for another user, maybe it got leaked through a third-party leakage. And that user never made that information available online. But just from a text corpus, like just this like big pile of text data, without these additional metadata from where each sentence was scrolled, there's no way of knowing which of these sentences, like precisely which one of these cell phone numbers should be private or not, because the model is just doing statistical modeling.
Yeah.
And I'm not sure like what objective should be optimizing there, just based on frequency, because just keeping or removing information about cell phone numbers as both are incorrect.
Yeah. Yeah, like you said, it's very contextual. So you kind of raised a couple of different points. One is like, is this an ill-defined problem? And I think it is an ill-defined problem. That's why like all of these, I don't know, applying formal methods to it is good in some situations. Like you can construct applications where the formal method and the assumptions that you're relaxing still offer some protections. But in this like very general purpose language model training case, it's very hard to understand what exactly it's doing. And I think that's partially just with any unstructured information like language or like speech, or anything like that. Like there's so much information you can get from speech too, including your tone of voice, your porosity, the content of your language, any other surrounding sounds that might be around you. There's so much stuff that can be inferred from that information, from like a short recording of someone's voice. That also like defining privacy in that space in a general sense can also be quite complicated. So I keep returning back to specifics and like specific applications, but I think it would be really good for us as a community to think about where our language models are going to be used and how they're going to be used.
I see.
Certainly, like chatbots are, you know, are the most like free form version of this, but yeah.
So like a context, as you said, is very application dependent, and it's a very hard problem. Like it's very subjective, and the nature is also very fluid. So what I want to ask you is like when sort of like the problem space became very subjective and very hard, is an approach like DP, which is like one extreme where we don't reason, as you said, it's the strongest guarantee we can draw. Is something like that could be a potential solution where we get a solution for everything. Maybe in like it's not application specific. We are getting the strongest guarantee by sacrificing utility. And is that approach, do you think we should be taking moving forward when even defining privacy preserving language model is quite hard by itself?
I think the language models that I've seen with DP that have worked the best have been trained on public data,
Mhm.
and then fine-tuned with DP on more sensitive data. But I think, like we discussed earlier, it can be really challenging for us to define what a record is in a way that would preserve meaningful notions of privacy. So before, when we were talking about like, let's take like building a vocabulary, for instance. Like if we're building a vocabulary off of like a set of chat transcripts, something that appears really frequently is people's usernames. So if you're doing something like BPE, you might have usernames appearing in your vocabulary. Do you want to call that memorized? Like it's kind of built into the model already, like it's explicitly memorized in a sense. But something like DP would have a hard time protecting against that, because the reason why the usernames are in the vocabulary is because they repeat so many times.
I guess this unit of privacy, no matter how you define it, it should come with some user agreement. People should know if they repeat having the same discussion in that unit. Let's say it's a sentence level. If you have the same sentence in many different ways multiple times, then you shouldn't expect that to be private anymore, and you should avoid. Like this should be something that people are aware of, and I think it's really hard to do that, because how do you want to tell someone not to have the same discussion with their friend or partner multiple times? It's really hard to define this unit notion of unit, a unit of basically privacy in differential privacy. And yeah, it makes it really challenging, and it's not really clear what does it mean for a language model to be even differentially private. Although differential privacy is a mathematical term, it's not clear what it means for a language model to be differentially private.
Yeah, I think here's another example that I just thought of. Let's say you and your friend are workshopping a paragraph of text. So you're collaborating on writing something, and then you're sending it back and forth via email to each other. So every time you send it back and forth to each other, it differs just a little bit. Is that considered a duplicate? It kind of depends on like how much they differ and how, what parameters you're using for your duplicate detection. But that could be one way that data ends up repeating many, many times.
Yeah.
But yeah, I think differential privacy is like a thing that you can do on top of other models, but it was mostly built for tabular data, where this is all really unstructured data, and it's a little bit unclear how to translate from one domain to the other.
Even in DP, we would need deduplication, right? Like,
yeah, probably.
And-
yeah.
But then the deduplication module itself should be checked for privacy. How do you train that? At the end of the day, you should try to, I don't know, it's the ML model or something that tries to put sentences together that like detecting duplicate sentences itself is a model that should be private, I think. It shouldn't be depending on, like, if you want to train DP, you should make sure that the duplication is also DP, which is also hard. And at the end, I think you should deal with this duplicates in a, like, defining the unit of privacy in a different way, basically saying that, I don't know, maybe all data from the same person should be just considered one unit of privacy. That's the best thing I can think of right now. But I guess that will be really hard for training language models.
Yeah, so other problems with that are like things like a company where information is shared across individuals in the company.
Yeah.
But just to elaborate on what the deduplication methods are, they actually currently, the two that we proposed here weren't machine learning based. They're actually quite simple. So one is, the suffix tree that you learned in your intro algorithms class, but scaled up and implemented in a much more parallel way. And then the other one is something with like min hashes. So it's looking for a bunch of hash collisions. You hash every single sequence in your data set and you hash it with many different hashes. And for anything where there's above a certain number of collisions, you do a more expensive computation. So looking at the edit similarity between those hash collisions. And you end up with like clusters, and then you can choose an example from the cluster.
So privacy is not a concern there because it's just an algorithm that I see. But still, like deciding to remove a sentence means there is some other sentence that was close to it. So it's not as clear of like how you can extract such a thing using the module, but still just the fact that you remove some sentence, I think leaks some information about other sentences.
Yeah, it definitely does. And people have tried like, not generating examples that were in the training data by doing things like Bloom filters, which are just like checking for n-gram matches. But not being able to generate a sequence also leaks some information about that sequence, namely that it was in the training set. So,
Yeah, maybe, you're actively trying not to generate it. Maybe there is a reason because it wasn't.
Yeah, it's like, oh, I can't get it to say this thing. It must have been in the training set.
Right.
But I know there's some DP people on the line, if any of them want to chime in on this discussion. I don't personally work with those models.
I have different questions. So all of the questions you listed are framed in a way that is not specific to language models. So probably intentionally. So are there lessons that can be learned by different communities that have like faced these kind of privacy problems already? And like what is like the specific thing about language models that is new? Is it just that it's regurgitating language? Is that like, I guess my question is, like technology has been around for a while, privacy problems have been around for forever. So obviously people have done research on this, and like what lessons can we take from like probably centuries worth of research on these topics?
Yeah, so a lot of what is actually in the paper that I presented here is from contextual integrity, which is a framework for thinking about privacy harms. That basically just argues that privacy is contextual and you need to take into account who the data subject is, the data recipient, data sender, and any other like social or legal constraints on that data. So I really recommend looking into that. There's also great work from Daniel Solov, kind of outlining different types of privacy violations. That includes things like data collection, data dissemination, inference, and something that I forgot the name of it, but it's essentially making decisions on behalf of someone based on the data that you've collected about them, which is, as we all know, going to become increasingly common. I think what's specific about language models, I've spent a lot of time thinking about this, and one thing is that they are kind of bad databases. Like sometimes they give you the information that was in the training set, sometimes they don't. It's not really clear when it's one or the other. So this was also in the harms of language models paper from DeepMind. But essentially that you have this like weird level of trust, but not trust about the information that you're receiving from the language model. You're also surfacing different types of information. So a language model acts as a search engine, it acts as a recommendation system, it acts as a terrible data set, terrible database. So those problems are all not new. Like search is not new, recommendation is not new, and the privacy concerns there are not new. But they come in a different form factor. and they lean towards certain types of information, like the example we talked about before with codecs and pulling out security keys via the language model, as opposed to looking in Google search. And part of that is just like protections that we built around other systems that we have. And part of it is the exact modeling task that language models work on.
Sorry, so something else I was curious about, I think you mentioned during the talk. So they're like definitely different ways of like phrasing emails, you know, for, like you said. But if we can cover like 99.99% of like use cases with just like templates, is that not good enough? Like, I mean, maybe it's not good enough for the 0.01% that doesn't get covered by it, but it, you know, it's still pretty good. So yeah, I don't really know what my question is. Like, all I'm saying is like, do you think it's like possible to nearly solve like this problem, like for at least for like PII or something that like, you know, has like, you know, a certain number of templates and is like most commonly phrased in like a certain number of ways?
Yeah, for like the text sanitization stuff. Yeah, definitely. And like for applications, it definitely helps. Like you should definitely be doing it. If you have a specific application, that also narrows down your scope a lot more. It makes things harder, like removing the information about the divorce. That would be really difficult to do in a text sanitization way. But for things that are formatted, and you should definitely still be doing it. I thought you were asking a different question, so I'll answer that one too, which is like if most of these memorized examples are not things that are that devastating to people. So there's a notion of like linkability, like if we can't trace back to the individual whose information this was, how big of a problem is this? And certainly if we don't have linkability, that's much better. There's also, it's also a question of like, what sorts of privacy concerns are you willing to accept? And what sort of mitigations can you put in place to try to make the ones that remain a little bit better? So even if it happens like, you know, 1 in some number of times, you have to evaluate like what that means for that person who has their information there, and what we can do to help prevent that. And it's different, and it's going to change, especially as the systems start to get trained on other types of data as well. For the security key, I think it was someone's like Bitcoin wallet, right? If you can link that back to the same wallet, that's pretty bad.
Can you hear me?
Yeah.
All right. First of all, thank you. I missed the first few minutes of the talk, so my questions might have been answered there. But so I guess like what's not clear to me is that like you're trying to solve a bunch of problems. So one problem is like the space of possibilities of like things that you can infer from like some text, especially if you have external information, is really big, right? Like the example about the divorce is a good one. So like that is one problem that you're trying to solve. But even the fact that someone will learn that someone is getting divorced, that's also like really subjective. Like you're it seems like you're trying to like solve different problems, and one of the problems like what can be inferred, and the other one is even if something that can be inferred about a specific topic, is that really private? And is that like I might care, but someone else might not care about a specific particular topic. So like I guess I'm not clear like what are like the different dimensions that you're trying to solve this problem in. Maybe you explained it earlier.
No, it's a good question. And like you said, it's trying to approach it from all of the dimensions, but it's because it's a difficult problem. So from the like technical side, just trying to quantify and write down different definitions of memorization and see if we can measure and predict when those occur for language models. You kind of mentioned this about like maybe some people don't care if their divorce is public. Yeah, it's definitely like the harm that sharing a particular piece of information brings up differs from person to person. Like, for example, if the information that you had a beer leaked out, if your community doesn't care about drinking, it's, you know, totally whatever. But if your community has a ban against alcohol or something like that, that could be pretty bad for you. So it is very contextual. And I think part of the challenge here and part of the like, I haven't mentioned this yet, but maybe one thing we should consider doing is giving people a little more control over how their data is used, especially as consumer products will, you know, use individuals' data to train on them. Not just in language modeling, but also like, you know, this is going on with recommendation systems and et cetera. So you can infer quite a lot of information from recommendation systems as well. But there's a lot of discussion in like, especially in the EU around how to give people control over their data. And this was kind of mentioned a little earlier, where, you know, if someone wanted to remove their data from the data set, that would be also pretty challenging to try to track down what example that was and then remove that from the model. There's like this whole other literature on model forgetting that has expanded. I don't think I fully answered your question, but hopefully I gave you some color.
No, definitely. So I think like trying to understand the problem, it might be useful to like differentiating between these different sub problems that need to be solved could like really be useful, because again, like I think some of them are really harder than like the others. Like contextual integrity provides a framework for like some of these contextual or subjective things, but what can be inferred from a language model is a much bigger problem, I think.
Right. Yeah, I agree. And also just inferring context is its own problem.
If there is no other question, let's thank our speaker for the amazing talk and the amazing follow-up discussion.
Thanks, guys. And if you have interest in trying your hand at this, there's a competition that I mentioned at the beginning as part of SPML for trying to extract training data from language models.
Yeah, I think that it's live now, the website and everything for it.
Yeah.
That's great, actually. All right, then see everyone next week. Just one update. I think the frequency of the seminar from now on will be like one break after every 2 talks. So it's balanced between bi-weekly and weekly frequency. So see everyone next week.
Thanks, guys.
Thank you.
Thanks for having me.
Bye-bye.